A pressing question looms over Tesla's Optimus Gen 3. Can Tesla reduce the robot's price sufficiently to transform it into a mass-market consumer product? Elon Musk's recent statements suggest not only that this is achievable, but that it's central to Tesla's strategy for commercializing Optimus. By leveraging a redesigned architecture, optimized materials, and Tesla's unparalleled production scale, Optimus Gen 3 could redefine affordability in humanoid robotics, potentially hitting a price point that competitors can only dream of. So, how much can the price of Tesla Optimus Gen 3 drop with the all-new design? Before we begin, please help us reach 11,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. Elon Musk has repeatedly stressed that Optimus must be priced below the cost of human labor in developed economies to achieve widespread adoption. In a 2024 shareholder meeting, Musk projected that, with sufficient optimization, production costs for Optimus could fall below $20,000. This figure is striking when compared to existing robotic platforms, such as Boston Dynamics Spot, which retails for approximately $74,500, or Figure AI's Figure 01, estimated at $100,000 to $150,000 for early prototypes. Achieving such a low price requires a revolutionary approach to design, eliminating inefficiencies while maintaining safety and functionality. The Optimus Gen 3 design represents a significant leap forward in efficiency. According to leaks and footage from Tesla's 2025 Investor Day, the robot is approximately 22 pounds lighter than its Gen 2 predecessor and incorporates 30% fewer mechanical components. This reduction simplifies assembly, lowers maintenance costs, and minimizes expenses related to quality control and inventory management, key drivers of mass production costs. Industry analysts estimate that streamlining a robot's mechanical structure can reduce assembly time by up to 25%, translating to significant savings according to the Robotics Manufacturing Report in 2025. Material choices further enhance cost efficiency. Tesla has reportedly transitioned from traditional aluminum and steel to advanced cast alloys and reinforced polymers for select external components. These materials, which are lighter and cheaper, can be produced at scale using molding or additive manufacturing techniques like 3D printing. A 2025 study by McKinsey on robotic production suggests that consolidating a robot's shell from dozens of parts to 4 to 5 major pieces could slash material and machining costs by 40 to 50%. For Optimus, this shift could reduce the cost of the exoskeleton by over $2,000 per unit at scale. A cornerstone of Tesla's cost reduction strategy is its reuse of existing automotive hardware and software. The full self-driving chip, which powers Optimus's AI capabilities, is the same one used in Tesla's vehicles, with over 1.2 million units produced annually in 2024 by Tesla Q4 2024 production report. By avoiding the need to develop a bespoke processor, Tesla saves an estimated $50 to $100 million in R&D costs. Similarly, cameras, sensors, and electric motors are sourced from Tesla's automotive supply chain, which benefits from economies of scale unmatched in the robotics industry. For instance, Tesla's ability to procure high-resolution cameras at $50 per unit, compared to $200 for competitors, significantly lowers Optimus's bill of materials. Internal estimates from Tesla's production team suggest that at a production volume of 500,000 units per year, the manufacturing cost of Optimus Gen 3 could range between $14,000 and $16,000 per unit. This is already competitive with the base price of a Tesla Model 3, which retailed for $39,990 in 2025. If Tesla offers financing or bundles Optimus with subscription-based AI services, the effective retail price could dip below Musk's $20,000 target, making it accessible to a broader consumer base. Tesla's pricing strategy extends beyond hardware costs, leveraging innovative business models to maximize affordability. Unlike traditional robotics companies that rely on high-margin hardware sales, Tesla could adopt a low-margin approach similar to its Model 3 and solar roof strategies. By selling Optimus near cost, Tesla could generate long-term revenue through software, updates, AI-powered subscriptions, or service contracts. For example, an Optimus as a service model could allow consumers to rent the robot for $50 to $100 per month for tasks like elder care, home maintenance, or meal preparation, mirroring trends in the service robotics market, which is projected to grow to $103.3 billion by 2030. This approach aligns with Tesla's target market: households, particularly those with elderly members, special care needs, or professionals seeking AI-driven assistance. While industrial robots can justify price tags of $50,000 or more, consumer robots require affordability akin to smartphones or laptops. A 2025 survey by Deloitte found that 62% of U.S. consumers would consider purchasing a home assistant robot priced under $20,000, especially if offered with flexible financing. Tesla's ability to offer monthly payment plans could make Optimus as accessible as a $500 smartphone spread over 2 years. Tesla's vertical integration provides a structural advantage over competitors. Unlike Boston Dynamics, which excels in technology but lacks large-scale manufacturing, or Figure AI, which depends on third-party suppliers, Tesla controls its entire production pipeline, from chips and software to factories. This allows Tesla to optimize costs at every stage. For instance, Agility Robotics Digit, deployed in Amazon warehouses, carries a price tag of $40,000 to $50,000 due to high U.S. production costs. In contrast, Tesla's Gigafactories, which produced over 410,000 vehicles in Q2 2025, provide the infrastructure to manufacture Optimus at an unprecedented scale. Tesla's Fremont factory is being retooled for Optimus pilot production, with plans to have several thousand units operational by the end of 2025. This scalability is critical, as economies of scale drive down costs. Historical data from Tesla's Model Y production shows that each doubling of output reduces unit costs by 15 to 20%. If Tesla achieves Musk's vision of producing 1 million Optimus units annually by 2030, unit costs could plummet to $10,000 to $12,000, a price point that would disrupt the robotics industry. How have operating and charging times improved after this big update? Among the most common inquiries about Tesla's Optimus is its operational endurance and recharge requirements, critical factors for potential buyers evaluating its practicality as a home or workplace assistant. As outsiders to Tesla's development team, pinpointing exact technical specifications, such as battery performance or mechanical details, poses a challenge. Tesla claims Optimus can operate for up to 20 hours daily with a 2.3 kilowatt-hour battery, a figure that sparks skepticism given the energy demands of humanoid robots. Let's dive deeper to assess the feasibility of this claim and explore how Optimus's task-learning capabilities could make it a transformative companion. Tesla's assertion that Optimus can function for 20 hours daily is ambitious, particularly with a modest 2.3 kilowatt-hour battery, comparable to that of a high-end electric bicycle. For context, Boston Dynamics Atlas, a leading humanoid robot, operates for approximately 4 to 6 hours on a 3.5 kilowatt-hour battery under intensive conditions. Human workers typically manage 8-hour shifts with breaks for meals and rest, whereas robots like Optimus may only require brief recharges. Assuming a continuous runtime of 6 hours per charge, based on energy consumption rates of similar robots like Agility Robotics Digit, which uses 2.5 kilowatt-hours for 5 to 7 hours. Optimus would need 3 30-minute recharge cycles to approach the 20-hour mark. This recharge model aligns with Tesla's use of high-efficiency lithium-ion cells, similar to those in its Model 3, which support rapid charging at up to 50 kilowatts. A 2025 study by McKinsey estimates that modern humanoid robots can achieve 80% charge in 20 to 30 minutes with advanced battery management systems. For household users, such brief pauses are unlikely to disrupt daily routines, as most won't require Optimus to operate continuously for 20 hours. Instead, its design prioritizes flexibility for shorter, task-specific sessions, distinguishing it from industrial robots built for relentless factory work. What sets Optimus apart is its ability to learn tasks from instructional videos, a feature that could make it an intuitive daily companion without requiring extensive user training. Equipped with 8 2D cameras on its head and powered by Tesla's full self-driving chip, Optimus leverages deep learning algorithms to interpret and replicate tasks. This mirrors Tesla's approach to autonomous driving, where neural networks process visual data to navigate complex environments. A 2025 report by Gartner highlights that vision-based learning in robots can reduce training time by 60% compared to traditional programming methods. Imagine a scenario where Optimus watches a cooking tutorial via its cameras and then prepares a meal autonomously, from chopping vegetables to cleaning the kitchen. This capability, demonstrated in Tesla's 2025 We Robot event, where Optimus replicated a recipe after a single video, could revolutionize household assistance. Similarly, for cleaning tasks, users could play a tutorial, and Optimus would mop floors or organize spaces while the owner relaxes. A 2025 Deloitte survey found that 68% of U.S. consumers value robots that simplify household chores, with 55% willing to pay a premium for autonomous learning features. The success of these tasks hinges on Optimus's dexterous hands, which account for approximately 80% of task precision, according to Tesla's internal engineering estimates. Modeled after human hands with 5 fingers of varying lengths, the latest iteration boasts 22 degrees of freedom, surpassing the 11 degrees of freedom of its predecessor and outpacing competitors like Figure AY's Figure 01 with 15 degrees of freedom. This advancement enables delicate operations such as handling an egg, manipulating battery cells, or watering plants, as showcased in Tesla's 2025 demo videos. Elon Musk has claimed that Optimus's hand can perform complex tasks like playing the piano or threading a needle, feats that typically require years of human practice. A 2025 study by IEEE confirms that hands with over 20 degrees of freedom can achieve 95% of human dexterity levels, supporting Musk's assertions. However, the increased complexity raises production costs, with each hand estimated at $5,000 to $7,000, or 30% of Optimus's total manufacturing cost. While Optimus's video learning capability is groundbreaking, it raises concerns about exposure to unsafe or malicious content. If Optimus can learn from any video, mechanisms to filter inappropriate instructions are essential. Tesla has not publicly detailed its content moderation strategy, but a 2025 UNESCO report emphasizes the need for AI systems to include robust safety protocols to prevent misuse. Additionally, the EU's AI Act, effective February 2025, mandates transparency in AI training data, which could complicate Tesla's deployment timeline. On the positive side, video-based learning accelerates Tesla's ability to refine Optimus's capabilities. By integrating Grok Voice AI, Optimus can also respond to verbal instructions, enhancing its accessibility for non-tech-savvy users. This synergy between visual and voice AI positions Optimus as a versatile assistant, with applications ranging from elder care to educational support. So, what exactly can the Tesla Optimus Gen 3 do in your house? Elon Musk has driven remarkable progress in enhancing Optimus's engagement with its surroundings. Its hands are no longer limited to grasping items. They can now execute highly delicate tasks, such as administering a massage. And when we describe it as gentle, we mean exceptionally so. With the addition of advanced tactile sensors, Tesla Optimus Gen 3 can finely tune its grip and pressure, delivering therapeutic massages with precisely the right level of force. Innovation remains a constant force with Optimus, and the 2025 model is set to impress with greater speed, agility, and versatility compared to earlier iterations. The Gen 2 version shed 22 pounds compared to Gen 1, already boasting a 60% speed increase over the original. And now Optimus can effortlessly maneuver through confined areas like factories, bustling streets, or busy restaurants. It can even ascend and descend stairs with impressive balance, reminiscent of a skilled gymnast. Delving into the finer details reveals where Tesla truly excels. Optimus's newly designed legs aren't just mechanical limbs. They're crafted to mirror the shape and flexibility of human feet, enabling natural walking and confident navigation across challenging terrains without stumbling. The upgraded neck, now with 2 degrees of freedom, enhances head movement, fostering more lifelike interactions and transforming Optimus from a mere machine into a relatable companion. Can these humanoid robots outperform Tesla's robot in terms of performance? If the humanoid robot race in 2022 was merely a battle between Tesla and Boston Dynamics, then by 2025, it has become a race between Tesla and more than 20 other robotics companies worldwide, because every week, every month, new humanoid robot products are being unveiled. But why is it that only Tesla's Optimus is being copied? Clearly, it's because Tesla's humanoid robot technology and design are good enough to draw the attention of other companies. It may sound harsh to say that Figure AI or most humanoid robot manufacturers in the Chinese market have copied Tesla Optimus, but it's evident that they drew inspiration from Optimus when developing and showcasing the latest generation of their robots in promotional videos. That's not a random coincidence, and of course, there's nothing negative about it. If Figure AI chooses to learn from the way Tesla introduces its new products, it might actually be a smart move. Tesla's release of the Optimus Gen 2 introduction video at the end of 2023 truly shook the tech enthusiast community because it was genuinely impressive. As of now, in 2025, several robots that are seen as challengers to the dominance of Tesla Optimus have unveiled their development roadmaps for humanoid robots. Most notably Figure AI, which has announced plans to produce 12,000 robot units per year, aiming for a larger goal of 100,000 units within 5 years. However, when looking at the broader picture of manufacturing capabilities, Tesla clearly holds the advantage with its 6 gigafactories and another facility currently under construction, expected to begin operations this year. This highlights the immense potential behind Tesla's plan for mass production of Optimus robots starting this year, with Elon Musk stating an initial rollout of 5,000 units. In contrast, Figure AI has only revealed a partial introduction to its Bot Q production facility, which is still under construction and being prepared for future large-scale humanoid robot manufacturing. Meanwhile, Unitree, a robotics company based in China, continues to share updates on its development progress and future plans, particularly with its Unitree G1 and H1 models, though it has not made any concrete announcements regarding mass production. That said, we believe that large-scale robot manufacturing in China wouldn't be a difficult feat, given the country's industrial capabilities. In contrast to the flashy technology displays of its competitors, Tesla rarely showcases new features for its humanoid robot, Tesla Optimus. The most recent update we've seen was an improvement in Optimus's gait. While videos showing robots walking are nothing new, Tesla has demonstrated clear progress over time since the release of the first version. The robot has gone from taking slow, tentative steps to walking confidently like a grown man. This highlights Tesla's true vision: to develop a robot that evolves like a human, one that is more relatable and closer to people than mere machines that can only run, tumble, or perform parkour, often with an astronomical price tag of up to $100,000. What we truly need is an advanced AI-supported humanoid robot that understands humans, equipped with a 22 degree of freedom, hand capable of handling any assigned task, from folding clothes and washing dishes to cleaning windows or cooking meals. This approach isn't limited to humanoid robots. Tesla has also showcased its capabilities in other areas, such as electric vehicles, most notably the Cybertruck and Cybercab. After years of development beginning with the reveal of their early designs, these two of Tesla's most radically designed vehicles were rarely leaked or talked about during production. However, at just the right moment, Tesla suddenly launched these products, shocking fans and sparking immediate desire to own them. On the other hand, vehicles like the Model 3 Highland or Model Y Juniper were also rarely revealed to the public during their development phase. They only came to light when Tesla decided to unveil them unexpectedly on a seemingly ordinary day, though it's clear the launch had been carefully planned in advance. Why did Tesla do this? Was there anything unique behind the development of Optimus? Have you ever wondered why Tesla has been almost silent about the humanoid robot Optimus? Why don't they constantly show off demonstration videos like their competitors? The answer may lie in Elon Musk's extremely clever and calculated strategy of keeping technological advancements under wraps, especially when it comes to breakthrough technologies. We've seen this before with the full self-driving software. Only when it reached a high level of accuracy did they release overwhelming updates. With the humanoid robot Optimus, this strategy becomes even more apparent. Revealing unique features too early could allow competitors to copy the ideas. We can clearly see that shortly after Elon Musk made impressive claims about Tesla Optimus, robot manufacturing companies, including both long-established firms and newcomers, began shifting toward humanoid robots with designs and features similar to Tesla Optimus. To get a more concrete perspective, we can look at a specific example. Figure AI, a humanoid robot company based in the United States, which aims to produce a fleet of 100,000 robots within the next 5 years. Setting aside performance and technical specifications, the design of Figure 2 alone marks a significant improvement over Figure 1. What is even more impressive is that Figure AI was only founded in 2022, making it a very new company, not one with decades of experience like Boston Dynamics. Yet they have progressed rapidly. The Figure 02 robot shares a similar build with its predecessor, Figure 01, standing at 5 feet 6 inches or 168 centimeters tall. However, like the Tesla bot, the latest design of Figure 02 includes several enhancements that we find impressive. Before the release of Figure AI's Figure 02, it was hard to deny that no competitor to Tesla Optimus was truly worthy of praise in terms of design. Whether it was the Unitree H1, G1, Boston Dynamics Atlas, or the Kepler Forerunner, none of these robots featured a design sophisticated or appealing enough to rival Optimus. To be fair, Optimus is still the most visually appealing humanoid robot on our list, although it has only been in the field for 2 years and is currently in its 2nd generation. The design of Optimus has already become a standard for humanoid robots. Standing at 5 feet 10 inches tall, its entire body is made of 80% plastic, cleverly concealing its metal frame. The prominent Tesla logo on its chest, combined with an LED light strip on its head, completes the look. This level of refinement has inspired many copycats. The design of Tesla Optimus Gen 2 is not the final version, as Musk has hinted that Gen 3 will be released later this year. However, every design and innovation seems to be trailing behind the Tesla bot, waiting for Tesla to reveal more ideas and special technologies so others can continue replicating those functions. In addition, this quiet strategy allows Tesla more time to focus on developing its new design, the 22 degree of freedom hand, which comes closest to the human hand's 27 degrees of freedom. Now, when comparing the hands of Optimus and Figure 2, we see a rather challenging situation because they are quite similar. As we mentioned earlier, although there are many humanoid robots today and the number continues to grow over time, you will notice that very few robots have a full set of 5 human-like fingers. Some have only 3 fingers, like the Atlas robot, while others have claw-like hands. However, Optimus and Figure 02 are among the few robots that feature 5-fingered hands, and both have hands that closely resemble those of a human. Elon Musk once said that having 5 fingers of varying lengths, like a human hand, gives robots certain advantages when it comes to handling objects with greater finesse. For the 4th generation Figure 02 robot, this means it has gone through 4 updates to reach 18 degrees of freedom. In the introduction video, Figure demonstrated highly flexible hand movements for its new generation robot. It appeared to move car parts between stations and then place those parts precisely in position. The truth is, as far as we understand, the current design of Optimus only includes 2 joints per finger. Tesla's engineers removed 1 joint, believing that fewer components would be better. However, it is clear that in the next update, with 22 degrees of freedom, they have decided to add that joint back. Both robots have 2 degrees of freedom for thumb movement, but Optimus only has 1 thumb joint. An additional thumb joint can affect the shape of the hand when grasping objects, there is a certain level of flexibility in the palm that many people might overlook. Elon Musk once mentioned that the 22 degrees of freedom in Optimus's hand could allow it to play the piano, which requires individual finger control, just like a human hand. Achieving this also depends on the number of actuators inside the hand. How would Tesla build the ecosystem? As seen in Tesla's videos and images introducing the Tesla Bot Gen 3 as a professional helper, these roles may seem obvious to humans, but they are not easy for a typical robot to perform. As a smart helper, Tesla Bot Gen 3 can handle all of these tasks: cleaning, cooking, childcare, and elderly care. Yes, the upcoming Gen 3 version promises significant changes and upgrades. Tesla has already demonstrated its ability to clean the kitchen, water plants, serve drinks, open trunks, bring groceries inside, and even check packages. With the latest version, Tesla Bot Gen 3 will be much smarter than Gen 2, with improved mobility and operational speed, showing that Tesla is the only company to have successfully brought multiple generations of humanoid robots into the real world. Emerging from an electric vehicle manufacturer, Tesla is gradually diving deeper into other goals, with its ecosystem now including SpaceX technology, Starlink, Neuralink, electric vehicles, the Tesla app, and even X and Grok AI. So when a customer begins using Optimus, they will be interested in all the integrated technologies and continue using them, which inadvertently increases Tesla's value. As Elon Musk mentioned, the Tesla bot will be capable of performing various tasks based on real-world needs. By 2026, Tesla plans to produce hundreds of thousands of Tesla bots and begin selling them to a broader range of customers. Tesla certainly has the resources to prove that the production of Tesla bot can scale at an incredible speed. The Tesla bot has already demonstrated impressive interaction capabilities, including dancing, serving cocktails, and engaging in conversations with attendees. These abilities highlight the potential to replace human roles in customer service and hospitality, industries that heavily rely on interaction, efficiency, and adaptability. They have achieved this level of interaction through advanced AI, enabling it to learn and quickly adapt to new situations. In hospitality and customer service, this adaptability can enhance the customer experience by providing personalized interactions. For example, the Tesla bot could gradually learn customer preferences and adjust its service to meet individual needs, its efficiency and consistency far surpassing traditional human roles. What is Tesla's strategy for producing $10,000 Tesla Optimus? Most robotics companies struggle to commercialize their products due to high production costs, with humanoid robots typically priced at over $50,000 or even $100,000. A prime example is Boston Dynamics' Atlas, which, despite nearly a decade of development, was never mass-produced and was ultimately discontinued. In contrast, Tesla has taken a completely different approach. Elon Musk has repeatedly stated that Optimus will be priced between $20,000 and $30,000, with the ambition of lowering it to just $10,000 through large-scale manufacturing. Tesla leverages existing technologies from its electric vehicles, such as batteries, motors, and sensors, significantly reducing costs. In Tesla's Q2 2024 financial report, Musk declared Tesla as the leader in humanoid robotics, with Optimus surpassing competitors in both technology and value. With the ability to perform thousands of tasks at a price below $20,000, it presents an unprecedented opportunity for mass adoption. Tesla has developed 3 generations of Optimus in just 2 years, with the finalized version set to be available for sale in 2026. The Fremont facility will serve as the primary production hub, according to Musk, and he believes that with large-scale manufacturing, the price of Optimus could drop significantly, just as Tesla has achieved with its electric vehicles. Tesla's Q1 2025 all-hands meeting saw CEO Elon Musk share critical updates on the company's most ambitious product yet, Optimus. According to Musk, Tesla aims to begin Optimus production this year, and the initial manufacturing run will be no small feat. When discussing Optimus production, Musk clarified that Tesla is internally targeting enough components to manufacture between 10,000 and 12,000 Optimus robots this year. However, since Optimus is an entirely new product, even producing half of that 5,000 to 6,000 units would still be a significant win for Tesla. The company also plans to scale up Optimus production substantially by 2026, with a goal of 50,000 units, or 10 legions of humanoid robots, by next year. How is Tesla able to produce the Tesla Optimus for under $10,000? Right after the U.S. president announced tariffs on imported cars and auto parts, Tesla stood out in the automotive industry by being shielded from Trump's 25% tariff. Tesla managed to avoid the tariff impact thanks to local manufacturing. The company's gigafactories in China and Germany do not supply Tesla vehicles to the U.S. market. Instead, all electric vehicles sold in the U.S. are produced at the Fremont factory in California or at Giga Austin in Texas. The same goes for the Tesla Optimus, which has been revealed to be slated for mass production at the Fremont and Texas facilities. This tariff on electric vehicles from China is as high as 45%, but keep in mind that Tesla enjoys a special rate of around 9%. BYD is at 17%, and SAIC faces 35%. So Tesla has one of the lowest tariff rates when it comes to electric vehicles, and I expect Tesla's competitive position to remain relatively the same despite any anticipated changes. Of course, this tariff has been raised multiple times due to China's retaliatory measures. Until tensions ease and the two markets gradually reach a more reciprocal tariff agreement, the significantly lower prices of imported components will help Tesla achieve its plan to produce the Tesla Bot Optimus for under $10,000. Additionally, Tesla may be able to offer this product at an excellent price, and it appears that it could be integrated into the full dry battery electrode process currently being implemented for 4,680 battery production in the coming months, something that will unlock further cost efficiencies. One piece of encouraging news is that Tesla has already begun hiring for more than 80 positions related to Optimus, and Elon Musk believes the company will indeed build a robot army consisting of 5,000 units in 2025. In a recent interview with U.S. Senator Ted Cruz, tech billionaire and Tesla CEO Elon Musk shared a striking piece of information. Tesla is aiming to produce 5 legions of Tesla Optimus robots within the next 2 years by 2026. According to Musk's phrasing, a legion can be understood as tens of thousands of units, indicating that the scale of Optimus humanoid robot production will be enormous. What's particularly notable is that these robots won't just be produced for sale on the market. They will first be used within the very factories where they are built. Tesla Optimus will be used to manufacture Tesla Optimus. This mechanism not only brings exceptional automation efficiency, but also promises to significantly reduce labor costs in the long term. According to Elon Musk, as the production process is optimized by the Optimus robots themselves, the cost per unit will drop dramatically. With the application of incentive policies, consumers could potentially own a Tesla Optimus robot for as little as $15,000, an incredibly competitive price compared to today's advanced robotics technologies. This development opens the door to a future where humanoid robots are no longer a luxury or science fiction, but a part of everyday life, from industrial manufacturing to personal assistance. If Musk's plan succeeds, the world will witness a new revolution in automation, with intelligent robots becoming a primary workforce across many industries. What are the positive impacts of tariffs on Tesla? The most affordable Tesla Cybertruck is now available in the United States with a $10,000 price drop. The long-awaited long-range version has finally been released, and it is truly an entry-level vehicle. With a starting price of $69,990 before shipping fees and applicable taxes, this version is $10,000 cheaper than the all-wheel drive model, which features dual electric motors and an estimated driving range of 325 miles. Clearly, this is a sign that Tesla has optimized its supply chain within the domestic market and reduced its reliance on foreign components and raw materials. This allows the company to enhance quality control and avoid geopolitical risks or disruptions in the global supply chain. Tariff policies encourage companies like Tesla to invest in domestic production lines, thereby creating more jobs and boosting economic growth in the United States. At the same time, Tesla is further motivated to expand its factory network, such as Giga Texas, to serve both manufacturing and export purposes. What are the signs that Tesla has started mass production of the Tesla Optimus? We may not know whether Tesla will be able to build 5,000 units of the Tesla Optimus this year, but we do know they have begun hiring for over 80 job positions related to Optimus at the beginning of the episode. Elon Musk appeared optimistic during Tesla's Q4 2024 earnings call, noting an annualized production rate approaching 2 million vehicles per year. However, the company's focus is shifting strongly toward artificial intelligence and robotics, with Musk boldly predicting that Tesla could become the most valuable company ever, worth more than the next 5 companies combined, thanks to advancements in self-driving technology and humanoid robots. With the goal of increasing production tenfold by 2026, Musk shared ambitious growth targets, predicting that he would achieve between 50,000 to 100,000 units next year. Tesla's future vision is to significantly ramp up production, a goal that Musk himself confirmed in his statement. These robots are designed to assist with manual tasks, such as lifting heavy objects, performing manufacturing duties, and potentially being used at home or in the workplace. With its first step into the field of humanoid robotics, Tesla appears to be making a revolutionary move toward addressing labor shortages and boosting productivity across various industries. The deployment of humanoid robots could have far-reaching social and economic impacts, raising questions about which jobs will and won't be required and how automation will unfold across certain industries. The company is making progress in reshaping the landscape of robotics and artificial intelligence, and stakeholders are closely monitoring the developments. Tesla Optimus was announced by Musk in 2021 and showcased as a prototype during AI Day 2022. They achieved this within 43 months. The robot demonstrates sophisticated capabilities, including walking, self-calibrating its limbs, and balancing on one leg. It can perform complex tasks such as gripping, sorting, and adjusting objects. Equipped with a range of sensors, Optimus autonomously perceives its environment and tracks the movement of its limbs. When can you actually buy a Tesla Optimus? Elon Musk seems to have the answer. Recently, he revealed a plan to produce 10,000 robots this year at the Fremont factory, with sales to customers expected as early as next year. This is not only a significant milestone for Tesla, but also a clear statement from Elon Musk. Optimus will become an essential part of the company's production and operations. To prepare for the expansion phase, Tesla is actively recruiting for multiple positions related to Tesla Bot, from production technicians to process managers. According to the latest job listings, there are currently at least 12 open positions at the Fremont facility, all dedicated to Optimus. This indicates that Tesla does not see Optimus as just an experimental project, but is gradually moving toward mass production. Beyond factory automation, Musk has also hinted at the upcoming Optimus Gen 3, expected to launch by mid-2026. This upgraded version will feature significant advancements, marking the transition from internal production use to broader commercial deployment. To achieve this, Tesla is setting an ambitious production roadmap. At the current stage, production is set at 1,000 robots per month, with the next goal being 10,000 units. As the company enters the expansion phase, production is projected to reach 100,000 robots per month. According to Elon Musk, these robots will not be limited to simple tasks like cleaning or organizing parts. Instead, they will be trained directly in the factory to collect data and adapt to more complex tasks. If the trials are successful, Optimus could play a crucial role in Tesla's electric vehicle production lines, enhancing efficiency and reducing monotonous or hazardous work for employees. The growing presence of humanoid robots excites and unsettles us, as the prospect of humans and machines coexisting is no longer a distant future. Is this a breakthrough that will bring unparalleled convenience, or the beginning of a sci-fi scenario where artificial intelligence spirals out of control? A more pressing concern is the possibility of robots gradually replacing humans in various industries. For this reason, despite their groundbreaking potential, humanoid robots continue to face skepticism and controversy. However, despite ongoing debates, leading tech companies remain committed to developing humanoid robots with the goal of integrating them as an essential part of society. Among this wave of innovation, one name stands out: Tesla Optimus. Beyond relying on the reputation of Tesla and Elon Musk, Optimus impresses with its advanced features, agility, and competitive pricing. More importantly, it is no longer just an experimental concept. Optimus is steadily proving itself as a reliable assistant in everyday life. So, what makes Tesla Optimus so reliable? We have witnessed a remarkable revolution in technology, especially in AI and humanoid robots. The concept of humanoid robots is not new, but what is remarkable is their strong comeback as a dominant technology trend. The frequent appearance of these human-like machines leaves us both amazed and concerned, as the prospect of a world where humans and machines coexist seems closer than ever. However, despite these concerns, leading technology corporations continue to push forward with research and development of humanoid robots, aiming to make them an essential part of everyday life. Amid this growing trend, one name is drawing more attention than any other humanoid robot: Tesla Optimus. It is not famous just because of Tesla or Elon Musk, but rather because of its unique features, capabilities, and pricing. In fact, it has proven itself to be the ultimate best homemaker. Most recently, during the fourth quarter of 2024 earnings call, Elon Musk once again emphasized Tesla's plan to ramp up Optimus production this year and next. This signals that Tesla is ready to go beyond being just an EV manufacturer. Elon Musk has revealed a significant step forward in Tesla's robotics ambitions. This year, Optimus will be deployed for trial use in factories and will also begin small-scale production on the assembly line in Fremont, California, with a target of up to 10,000 robots. Tesla is officially hiring engineers to prepare for mass production of Optimus, as seen in its job listings. Tesla's website currently shows at least 12 open positions, ranging from production technicians to manufacturing managers and process supervisors at the Fremont facility. All these roles are dedicated specifically to the Tesla bot. This new wave of job postings appeared just days after Elon Musk confirmed the start of Tesla bot production. Previously, the Fremont factory had deployed a few dozen Optimus units in demo videos. These robots will be trained directly in the factory environment to collect data and familiarize themselves with various tasks. If the testing process goes smoothly, Optimus may not be limited to simple tasks like cleaning or organizing batteries, but could also participate in certain stages of the electric vehicle production line. Additionally, Elon Musk asserts that everyone will want to own an Optimus, as it can perform any task you request. Its long-term value will surpass that of all Tesla products combined. And once Tesla reaches an annual production capacity of 1 million robots, Optimus will cost half the price of an EV, under $20,000. Ultimately, Tesla plans to produce billions of these robots, a bold promise for humanity. As we can see, Optimus is designed to mimic humans as naturally as possible, featuring a humanoid body shape, but without the fully expressive face of the Amica robot. Instead, it has a black head with an LED strip, making it appear more friendly and less intimidating. From the moment it was introduced, Optimus has demonstrated its potential to become the perfect household assistant. Through Tesla's demo videos, people have seen not just a machine moving fluidly, but also a capable helper, ready to clean, pour drinks, receive packages, or water plants. Elon Musk believes that if Optimus proves to be truly useful, not just a few million, but potentially all 8 billion people in the world will want one, maybe even two. Optimus Gen 3 is not limited to the tasks mentioned above. It can sort clothes, prepare meals, assist with caregiving, and even operate on rough terrain thanks to its agile and flexible mobility. Of course, in the early stages, the number of tasks Optimus can perform is still limited. But just like humans, the more it experiences and learns, the smarter it becomes. With each update, similar to how Tesla trains its full self-driving software with increasing precision, Optimus will absorb more data, refine its skills, and expand its ability to handle various tasks. The development of Optimus will explode, positioning Tesla as a pioneer in a new field, just as it did with electric vehicles. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.